Hi, in this video we are going to study the Laplace transform of finite duration signals. Now, first of all, let us define what we mean by a finite duration signal. Okay, x of t is a finite duration signal if x of t takes non-zero values in an interval t1, t2 over the time axis. And outside this interval, x of t is equal to 0. Okay, where t1 and t2 are finite and t2 is greater than t1. So outside this interval, x of t is equal to 0. Okay, before continuing with the Laplace transform, we are going to assume that x of t is absolutely integrable. Also, let us assume that x of t is absolutely integrable. In other words, when we integrate magnitude of x of t, and of course our integration limits are now from t1 to t2, the integral must be finite. Okay. Now let us look at the Laplace transform of x of t. X of s is equal to, from minus infinity to plus infinity, x of t e to minus st integrated with respect to t. Here s is sigma plus j omega. So this is a complex variable. And in fact, x of s becomes the integral from t1 to t2 of x of t e to minus st integrated with respect to t. Now, if we look at magnitude of x of s, magnitude of x of s is magnitude of this integral from t1 to t2 x of t e to minus st integrated with respect to t. Okay, in fact, this is the magnitude of the integral from t1 to t2 x of t. Now let us substitute sigma plus j omega instead of s, e to minus sigma t, e to minus j omega t integrated with respect to t. we have magnitude of this integral. So obviously the integral is complex valued, so we have the modulus of the integral. So this is less than or equal to, remember, magnitude of an integral is less than or equal to integral of the magnitude of the integrand. So from t1 to t2, magnitude of x of t, then we have magnitude of e to minus sigma t, magnitude of e to minus j omega t, integrated with respect to t. Now, magnitude of e to minus j omega t is equal to 1 because remember, the real part is cosine omega t, imaginary part is minus sine omega t. So cosine square omega t plus sine square omega t is 1, and therefore the magnitude is 1. E to minus sigma t is always positive, real valued and positive. Therefore, this is equal to e to minus sigma t. Okay. Now, for this expression, we can find an upper bound as follows. We take the maximum of e to minus sigma t outside. That means we find the maximum value over the interval from t1 to t2 of e to minus sigma t and take it outside the integral. Here sigma is completely arbitrary. So the remaining part of the integral expression is from t1 to t2, magnitude of x of t integrated with respect to t, but this is also finite. The integral of magnitude of x of t over this interval is finite because we have assumed that x of t is absolutely integrable. Therefore, this expression is always bounded. Therefore, we have shown that magnitude of the Laplace transform is always finite for any s over the s-plane. Okay. Therefore, we have the following important conclusion. Therefore, x of s exists for all s, which means that region of convergence is the entire S-plane. So we have obtained this important result. If we have a finite duration signal and if the signal is absolutely integrable, then its Laplace transform always exists and the region of convergence of the Laplace transform is the entire S-plane. Okay, now let us see an example to illustrate this conclusion. Okay, we have seen that if we have an absolutely integrable signal with finite duration, Laplace transform of this signal always exists, and the region of convergence of the Laplace transform is the entire S-plane. Okay, let us see an example now. x of t is equal to e to t for t between 0 and 1 and 0 otherwise. So obviously this is a finite duration signal. The duration of the signal is equal to 1 and it is integrable, absolutely integrable and equivalently integrable over this interval. Okay, so Laplace transform will exist and we are going to see that at the end the region of convergence is the entire S-plane. Okay, x of S is equal to, from minus infinity to plus infinity, x of t e to minus st integrated with respect to t. Now the integral is from 0 to 1 because x of t is 0 outside this interval. And in this interval it is equal to e to t. So we have e to t multiplied by e to minus st integrated with respect to t. From 0 to 1, okay, we can combine these two exponential functions as e to 1 minus st integrated with respect to t. So this is 1 over 1 minus s e to 1 minus st evaluated at the integration limits, which means that we have e to 1 minus s when we substitute t equal to 1, and then we have, when we substitute t equal to 0, we get 1 divided by 1 minus s. Okay, this is the Laplace transform of x of t. Okay, when we look at this expression, we see something strange. In fact, we have just obtained the result that for finite duration signals, the region of convergence must be the entire S-plane. But here, S equal to 1 appears to be a singularity, namely a pole of x of s. And remember, we have seen that poles are always outside the region of convergence. The region of convergence must not include any pole. So, do we end up with a contradictory result? Okay, we'll see that, in fact, s equal to 1 is not a pole. So, is s equal to 1 a pole of x of s? The answer is no in this case, because if we look at the numerator, okay, we can express the exponential function in terms of its Taylor series expansion as 1 plus 1 minus s plus 1 minus s squared divided by 2 factorial, etc. So this expression is the Taylor series expansion of e to 1 minus s. Then from this expression we subtract 1. And then we divide this expression. In fact, I should put the equality here. Then we divide this expression by 1 minus s. Okay. And now let us look at the numerator expression. The 1 in the Taylor series expansion will cancel out with this 1 over there, and we will have 1 minus s plus 1 minus s squared divided by 2. 2 factorial is 2. Then we have, let me write one more term, 1 minus s cubed divided by 3 factorial, and 3 factorial is 6, etc. Okay? All this expression divided by 1 minus s. So we will have 1 minus s cancelled by 1 minus s. We have 1 here. And the second term of the now series expression is 1 minus s divided by 2. And the next one is 1 minus s squared divided by 6, etc. Okay? So s equal to 1 is not a singularity. Okay? So s equal to 1 is not a pole. It is not a singularity of x of s. In fact, in the theory of functions of a complex variable, complex valued functions of a complex variable, s equal to 1 in this case is a removable singularity. So the singularity disappears, in other words. Therefore, the region of convergence of x of s is entire S-plane. Okay. So for finite duration signals, if the Laplace transform exists, that means if the function is absolutely integrable, its Laplace transform will exist, and the region of convergence will be the entire S-plane. Thanks for watching.